In this lecture, first topic we are going to cover is discovery of electron. Discovery of electron. So discovery of electron, it is done by discharge tube experiment. And this discharge tube is in front of you. You know, under normal condition of pressure, gas is a poor conductor of electricity. Now, the pressure is reduced, and what happened? Gas becomes conducting, and electricity starts flowing through the gas. Okay, inside there is a gas. Okay, if we increase the pressure, then gas is poor conductor. But if we decrease the pressure of the gas, it becomes conducting. His electricity starts flowing through the gas. First of all, William Crookes was the scientist, that is William Crookes, that studied the conduction of electricity through gases at low pressure, and he performed the experiment in a discharge tube. This is the first glass tube. This one is glass tube. Okay. Made up of hard glass. Okay. And it is sealed at both the ends and fitted with two metal electrodes. See, these are the two electrodes. One electrode and second electrode. These are the two electrodes. Okay. Okay. This is the hard glass tube, and it is sealed at both the ends, and it is fitted with two metal electrodes, as it is shown in this figure, right? So these are the two metal electrodes, hard glass tube. Okay. Electrodes are connected to a source of high voltage. See, electrodes are connected to a source of high voltage. High tension battery or induction coil is used, and a tube is connected to a vacuum pump. Tube is connected to a vacuum pump, and electrodes are connected to high voltage battery. So this is the setup of cathode ray discharge tube. What is cathode ray discharge tube? First, there is a hard glass tube, is sealed at both ends. At both ends, it is sealed and fitted with two electrodes. Fitted with two electrodes, and the electrodes are connected to a source of high voltage. Okay, and cathode ray, this hard glass tube is connected to a vacuum pump, so that we can reduce pressure inside it. Whatever pressure is inside, it can be reduced by using vacuum pump. The discharge tube, it is filled with a gas under study. That depends on us which gas we are taking inside the tube. Okay, so we observe the following things. First thing, that I will take it on the other page. Okay, this is the setup of cathode ray discharge tube. Okay, now what happened? First observation, under normal conditions. What is normal condition? That is 1 atmosphere pressure. Under normal condition of pressure, that is 1 atmosphere pressure, nothing is observed. Even by applying high pressure. Sorry, by applying high voltage. High voltage of the order of 10,000 volt. What it means? Tell me. As pressure is normal, that is 1 atmosphere, then nothing is observed even by applying high voltage of 10,000 volt. It means that gas does not conduct the electric current. Okay, so this is the first observation, that if pressure is high, high means normal, is 1 atmosphere, then there is no observable things happening inside the tube, even if we apply very high voltage of the order of 10,000 volt. So it indicates, or it means, that gas does not current the electric, does not conduct the electric current. Now, second observation. Now what we do, as the tube is attached to vacuum pump, so we slowly reduce the pressure. Now what we do, the pressure inside the tube is slowly reduced. By using vacuum pump. So we use the vacuum pump and start reducing the pressure slowly. So when the pressure is reduced to 10 raised to power minus 2 atmosphere, the gas is found to emit light. And the color of the light depends upon the nature of the gas. These different gases will emit different color of the light. So see, in the first case, when pressure was normal, even applying high voltage, nothing is observed. That means gases does not conduct the electric current under normal pressure. But when we increase the pressure, when we decrease the pressure by using the vacuum pump and pressure is reduced to 10 raised per minus 2 atmosphere, then the gas is found to emit the light. And the color of the light, it depends upon the gas, because when different gases are used, we get different color of the light. Now, next observation. The emission of the light is observed at 10 raised per minus 2 atmosphere. The emission of the light ceases when the pressure is reduced to 10 raised to power minus 4 atmosphere. But now walls of the discharge tube opposite to the cathode start glowing. With the faint greenish light, that is called fluorescence. But we call it as fluorescence. See, this is cathode. Now opposite to the cathode, this is the opposite to the cathode. This part start glowing. Okay, so this is the experiment. Now this experiment, what it shows? It shows that fluorescence is due to the bombardment of the glass walls of the tube by the rays that are emitted from the cathode. And these rays are, that's why called cathode rays, because they are moving from cathode to anode. So now we can see this experiment shows that the fluorescence is due to bombardment of the glass walls the tube by the rays emitted from the cathode. And these rays are called cathode rays. That means cathode rays are originated from cathode. moving from cathode to anode. See, cathode is negatively charged and anode is positively charged. So obviously, cathode rays have negative charge because it is moving towards positive electron. It is negatively charged. So now question is, what is the origin of cathode rays? What is the origin of cathode rays? First of all, cathode rays are initially originated from cathode material. Cathode rays, they are initially originate from the metal. Originated from the metal. Okay. Which constitutes the cathode. Means cathode, the electrode material, that is the origin of cathode rays. And these are also formed to the bombardment of the molecules of the gas inside the discharge tube by the high speed electrons. High speed is particles, which are actually electrons, which are emitted from the cathode. So that means, what is the origin of cathode rays? First, from the material of the cathode, that is metal, constitute cathode, and then these electrons, when strike to the gas molecule is ionized. Let us say only one electron it emit. So these are also formed due to the bombardment of the gas molecules inside the discharge tube by the ionization of the gas molecules. Okay, so Piyush is right that air gets ionized. First that, and second is the material of the cathode. So material of the cathode as well as by the ionization of the gas, these are the origin of cathode rays. Cathode rays are emitted from the cathode material as well as they are formed inside the cathode and anode, in between the region between anode and cathode. Okay, the origin. Now come to the properties of cathode rays. First is cathode rays, they travel in a straight line. Cathode rays travel in straight line. Second, cathode rays are made up of material particles. Cathode rays are made up of material particles. Because if we place a paddle wheel in between in the path of the cathode rays, it start rotating it. So how do they rotate? Because they consist of material particles, only then they can rotate the pedal. Okay. Then cathode rays consist of negatively charged particles. Consist of negatively charged particles. Then cathode rays, how do we know that they consist of negatively charged particles? Because when yes, because when electric field is applied, when we apply the electric field, then they deviate towards positive plate. They deviate towards positive plate. Otherwise, they move in a straight line in the absence of electric and magnetic field. But whenever electric field is applied, or whenever magnetic field is applied, they start deflecting in a direction which shows that they carry negative charge. Okay. Then next is cathode rays produce heating effect because they are material particles. Okay, so whenever they strike with the metal foil, obviously later gets heated. Then cathode rays produce X-rays. Produce X-rays when they strike on the yes the surface of hard metal. Because when they strike to the surface of hard metal, they get stopped at once, and therefore there is an acceleration, and due to that energy is released in the form of X-rays, because kinetic energy is converted into another form of energy, that's why rays are emitted, that is called X-rays. And hard metals such as tungsten, copper, molybdenum means heavy metals. When they strike with the heavy metals, only then they produce X-rays. So then cathode rays can pass through tin foils of metals like aluminium. But see, if thin foil of metal is there, then they can pass through it. But if we make it thick, then they can be stopped. Okay, and if they are stopped, obviously they will produce X-rays. Okay, or cathode rays. Cathode rays again ionize the gas through which they pass. Then cathode rays affect the photographic plate. Cathode rays affect the photographic plate, and this is called fogging. Called fogging. Then come to the fluorescence part. That when cathode rays strike against the glass surface, or a screen coated with zinc sulfide. Because zinc sulfide is a fluorescent material. They produce they produce fluorescence. And what is fluorescence actually? It is a simply glow, okay, where the electrons strike. That is called fluorescence. So, properties of the cathode rays is all properties of the cathode rays. What they show that they consist of material particles that are negatively charged. These particles constitute the cathode rays, are called electrons. That means actually cathode rays are stream of electrons. Stream of electrons. Cathode rays are simply stream of electrons. Okay. Now, when this cathode ray is modified, so first we cover the cathode rays. Now, when anode is perforated, so what happened? The cathode ray discharge tube with perforated anode. So then what happened? Perforated anode or perforated cathode? Recovery of proton, that is by perforated anode, cathode, sorry, is discovery of proton. Here, leave it aside. This is like perforation in the cathode. So, whenever we have perforated cathode, then this tube is used for the discovery of a proton. Discovery of proton. Let us take it like this. Okay. In high voltage, anode is complete, but cathode is perforated. One thing, I will make it by my own. Okay. See, this is a tube. anode and cathode is perforated. Attached to high voltage battery, same to vacuum pump. Okay. And cathode rays are moving towards anode. This is anode. One is cathode. This is perforated. Cathode. This is high voltage battery. Okay. So this is modified cathode ray tube. Now as it is discovered that atom has electrons. From the cathode ray, it is clear that atom has electrons. So by using that process, and that atom is electrically neutral, it was already discovered that atom is electrically neutral. Okay. So emission of negatively charged electrons from the atom of the gases in the discharge tube, that suggests if some electrons are emitted by the ionization of the gas, obviously there are some positive charge particles must also be present in them. Now see, if one gas emit one electron, other gas may emit two electrons depending upon the nature of the gas, and at the same time mass is also different, charges may also be different. If charge is even same, mass is different of different gases, charge to mass ratio is different. Charge to mass ratio is different for different gases. That's why different gases give different particles of anode rays. That's why anode rays depend upon the nature of the gas. That was your question, right? Actually, Goldstein did this. Goldstein modified the discharge tube by using perforated cathode. And on reducing the pressure, he observed a new type of luminous rays passing through the holes or perforations of the cathode and moving in a direction opposite to the cathode. So these rays are called anode rays, positive rays, or canal rays. These rays consisted of positively charged particles moving from the anode and away from the anode, right? Because they are moving away from the and initially they were named as positive rays or anode rays, because they are coming from the, seems like coming from the anode, or canal rays. Okay. Now, what is the origin of anode rays? So, beta, Kaka, did you understand why there is a different nature of anode rays depending on the nature of the gas? So, beta, see, if we have hydrogen gas and electrons strike on the hydrogen, so obviously it will lose one electron. So what is left? H plus. That is a proton. If we have oxygen gas and it lose one electron, it is O plus. Obviously, it is not a proton. Its nature is different. Its charge to mass ratio is different. Yes. What? Why anode rays? Cathode rays does not depend upon the nature of the gas. The question. Yes, actually, in cathode rays, there are electrons only, and in any atom, the charge and mass of the electron is same. So, whatever material we have used, if electrons are emitted from it, 1, 2, 3, whatever, so every electron has same charge and same mass. So, its charge to mass ratio is same. It is independent of the nature of the gas or nature of the material of the cathode. Huh? Just speak loudly. Yes, beta. Means in case of cathode, you know, electrons are the stream, means stream of electron is cathode rays. So electrons are emitted. Electrons are emitted from hydrogen or oxygen or any metal. Its nature is same. They have same charge. They have same mass. So charge to mass ratio is same. It is independent of the nature of the gas as well as on the nature of the material used, on the metal or cathode. Any cathode can be used because electrons are emitted in that case. But here cathode rays, sorry, anode rays are positively charged metal, gas ions. Positively charged gas ions. Okay. Oh, so now origin of anode rays. Origin of anode rays. So anode rays positively charged particles are there, constitute the anode rays. When they are formed, positively charged particles constitutes the anode rays. They are formed when electrons are knocked out from the atoms. Or molecules of the gas in the discharge tube. Okay, by the particles of the fast moving cathode rays. Like I told you earlier, that if we have a gas particle or gas atom or molecule, an electron strike it, electron is knocked out of it, so this is formed, and this is called anode rays. Okay, so anode rays, they are not emitted from anode. Anode rays are not emitted from anode, but from the space between anode and cathode. Keep in mind, cathode rays are emitted from the cathode material as well as the space between anode and cathode. I said anode rays, they are emitted, anode rays are not emitted from the anode, but it is from a space between anode and cathode, right? Because they are obtained by the knocking out of electron from the gas atom or gas molecule. But cathode rays, they are emitted from the cathode material as well as they are emitted from the cathode material as well as the space between them by the ionization of the gas, right? So if gas inside the charge tube is hydrogen, then the anode rays are actually the protons. So these are the lightest particle, they are known as proton. So what is the properties of anode rays? Are just opposite, like cathode rays travel in a straight lines, so anode rays also travel in straight line. Both travel in straight line. Okay. Anode rays Cathode rays consist of material particles, anode rays also consist of material particles. In case of cathode rays, they are electrons. In case of anode rays, they are positively charged gas ions. Cathode rays are deflected by electric and magnetic field. Anode rays are also deflected by electric and magnetic field. But deflection is as expected from a positive ion. Means it deflected towards negative state. And then the value of positive charge on the particle of the anode rays that depend upon the nature of the gas. Value of the positive charge on the particles consisting of anode rays depends upon the nature of gas. And charge to mass ratio also depends on the nature of gas. Nature of the gas in the discharge tube. Okay, but in case of cathode rays, charge to mass ratio is same. It is independent of the nature of gas as well as material of electrode. It is independent. Now let us define electron and proton. What is the definition of electron and proton? Very good. So it is a electron is a fundamental particle present in an atom carries one unit negative charge. One unit is actually 1.602 into 10 raised to power minus 19 coulomb and have negligible mass. Negligible mass of the order of 9.11 into 10 raised to power minus 31 kg. Is 1 upon 1837 of the mass of hydrogen. Okay. Now proton. Proton is again a fundamental particle in an atom. Carries, because it has, hydrogen has only one electron. It can lose one electron only, and it has one proton, one neutron, one electron. So when electron is lost, so H plus, that means it has one proton. It carries 1 unit positive charge, 1 unit positive charge means again 1.602 into 10 to the minus 19 coulomb. That is the 1 unit, and 1.67 into 10 raised to power minus 27 kg mass equal to that of hydrogen atom, and that is regarded as 1 unit mass. Okay, that's all for today. Okay, that's all for today. Structure of atom. We'll continue a discussion of this chapter. Each and every topic we'll cover during our class 11th. All the topics I will cover along with your JEE and NEET questions. It is all free of cost. So enjoy learning. Thank you so much.